What do you think we can do with this one?
I think we can try integrating the original equation first.
Okay, but here they say I sub n minus 1, I sub
So do they just
minus 1.
to substitute it?
All right, yeah, so let's substitute minus 1 for n. All right, so I sub minus 1 is the integral from 0 to 4 over 3 of 1 plus x squared to the, that becomes minus a half, right? With respect to x, which is the same as the integral from 0 to 4 over 3 of, we can write this as 1 over the square root, and that's the square root of 1 plus x squared with respect to x. All right. What do you think of this?
Yeah, it's fine.
All right. So how do you think we can integrate this thing?
I know in the formulas we have a specific, if we integrate this, we can get like I forgot which one, but is it cosh inverse or shine inverse? I forgot.
Okay. So if you go to page 6 of MF19, you find that one there. You find the special result under differentiation that if you differentiate r shine of x, you get 1 over root of 1 plus x squared, which means if we do the reverse, if we integrate 1 plus root of 1 plus x squared, we should get r shine of x. So we are expecting this to be r shine of x from 0 to 4 over 3. Okay, so that's what we're having right here. Now, again, in MF19, we know that r shine of x is ln of x plus root of x squared plus 1. So when we substitute 4 over 3, we'll be having ln of 4 over 3, and that's going to be plus the square root of 4 over 3 squared plus 1. That's essentially 9 over, actually 16 over 9 plus 1. So it's 25 over 9. And the square root of 25 over 9 is 5 over 3. Okay, so 5 over 3. And ln of this should be basically ln 3. Okay, so that's what we then eventually get. All right, I hope you understood what we did here.
Yeah, I understood.
Okay, nice. Now on part B, it says by considering the derivative with respect to x of 1 plus x squared to the half n, or otherwise, show that that is that and that and that. All right, it's fine. Let's work this one out. Okay, so we're saying that we have to consider this, okay, this derivative. So let's differentiate with respect to x. X of x plus, sorry, that's 1 plus x squared, right? 1 plus x squared to the half n, okay? And we do products, so it's going to be 1 plus x squared to the half n times the derivative with respect to x of x plus x of the derivative with respect to x of 1 plus x squared to the power of half n, so that when we do the differentiation, we get 1 plus x squared to the half n, and this derivative is 1, like we said, and that's plus um, half n of x, and that's off because we're differentiating this, right? So we've brought down the half n, and the x is this x. Then we're going to differentiate 1 plus x squared to give us 2x, right? And we're going to have 1 plus x squared to the half n minus 1. All right. Is this better? Do you understand how I've done this?
Yes.
So 2 goes into this. So that will be having 1 plus x squared half n plus n of x squared of 1 plus x squared, all right, to the half n minus 1. So this is what we get when we do the differentiation, okay? 1 plus x squared to the half n plus nx squared of 1 plus x squared to the half n minus 1. All right. So now that we have this, the question says we should show that this is the thing, okay? So we know for certain that since this is differentiation, if we do the reverse of differentiation, then that's integration, okay? So basically we are saying if we integrate 1 plus x squared to the half n plus n of the integral of x squared of 1 plus x squared to the half n minus 1. Okay, so all this is with respect to x. So I want to do them separate. So dx, and this is with respect to x. If we do the reverse, we should get back the x of 1 plus x squared to the half n. So 0, 4 over 3, 0, 4 over 3. And on the right side, whatever we get should be 0, 4 over 3. Okay. All right. Now, for this thing here, we can say that it is actually in the same form as I sub n. So we can say that it is actually I sub n. Can we say that?
Yeah.
Okay. So we have I sub n here. And then that's going to be plus n of. And for this particular part, we also want it to be in the same form or manner because we want it to be in this particular form, okay, so that we can use the reduction like the formulas. We can use the I sub n formula for it. Now, one way we can do that is to say this is the same as the integral from 0 to 4 over 3 of, and for x squared, it's like 1 plus x squared, but with a minus 1, okay? And that's of 1 plus x squared to the half n minus 1 with respect to x, okay? So we try to make sure that we express it so that it has a 1 plus x squared on it, all right, for simplification. And on the right side, we're substituting 4 over 3. So we have 4 over 3 of 1 plus 4 over 3 squared to the power of half n, right? And that's going to be minus 0. All right. So we have I sub n plus n of. Now, if we take this to multiply this, the 1 plus x squared to multiply 1 plus x squared to the half n minus 1, we will get the integral from 0 to 4 over 3 of 1 plus x squared to the half n. Okay, because the powers add up. So minus 1 plus 1 is 0. So we're left with half n. And minus 1 to multiply again this thing. Here we say by the x would be minus of the integral from 0 to 4 over 3 of 1 plus x squared to the power of half n minus 1 with respect to x is equal to, and on the right side, that's 4 over 3 of, what's 1 plus 16 over 9?
I'm getting 25 over 9.
25 over 9. But that's to the power of a half n, all right? Yeah, like that. So we have I sub n plus this part, considering the form of I sub n, it is actually the same. So it's going to be n of I sub n. And that's going to be minus, here the n should also affect, right? So it's
Yeah.
minus n of I sub what? Now half n minus 1. Remember, the form is half n. So we have to factor out a half. So for, half n minus 1, if we factor out a half, we will get n minus 2, basically, right? Half of n minus 2. So in this case, this will make it I sub n minus 2. And this is equal to 4 over 3 of the square root of 25 is 5. The square root of 9 is 3. All to the power of n. Okay. So what do they want? They say here in the question, sorry, here, we should express it in this way. Okay, actually in this form, like they have it. Okay. So I think you can see that for these two, we can factor out I sub n. Sorry, factor out I sub n, all right. And we can have it as n plus 1 of I sub n. Is that right?
Yes.
4 over 3 of 5 over 3 to the n. So we can actually say n plus 1 of I sub n minus, is equal to, right, just as they have it, n of I sub n minus 2 plus 4 over 3 of 5 over 3 to the power of n. And this is actually what they want us to have. So shown. Okay, I don't know if you understood how we did it.
I understood.
All right. So that's basically how we would handle such a type of question. A little bit tricky, but I think it's all right.